Hello, everyone. Welcome to ITS 450. Let's get started for today. So just a few reminders. Last week, you had your exam one. I'm grading those. I've graded some of you. Hopefully, I'll have those by Thursday. I'm thinking I'll have everything graded by then. So we can, you can ask questions on the exam on that day, about the exam. Then on Thursday, I went over kind of a lecture, I think, on the project. So I remind you, please work on the project. You're going to have spring break coming, not spring break, sorry, fall break coming up Monday and Tuesday. So maybe use up that time, if you haven't done so already, to start working on the project. Remember, we had said, in the near future, I kind of want you to do a demo of where you are in that project. You should have the website already loaded. Even though you haven't finished the work, you should show it already loaded on your VM and everything. Okay. Then, of course, we have our practical exam this Thursday. Remember, it's going to be about the buffer overflow lab. It's just going to be one problem. So it'll be from 6 to 8, I guess. And I'll give you some hints on it. I'll post the exam question, right around 6 o'clock on Thursday. So please don't miss that. Make sure you're studying for that. So I think, we spoke on the buffer overflow vulnerability, and if you still have questions about that, please ask or send me an email about it. All right, but as I said, we are pretty much at this point done with the C++ focus of this course. And now after we're done with the practical exam on Thursday, we're just mainly going to focus on web security. And as you have seen, I have already started with web security, software assurance for the web by assigning the project. And today will be our first sort of official topic on this. We are going to cover a topic called same origin policy. Okay, web same origin policy. So I'll talk about that today. Okay, and it's actually a lab. So today it's a very easy, short lab, just meant for the practice. As you will see, it's pretty straightforward. And then and that will be it. Next Tuesday, I guess there's no class, but next Thursday we will start another lab called the SQL injection lab, which is a much longer lab. So that one will take probably a week and a half to 2 weeks to complete. This lab that we're going to do today, the same origin policy, is pretty straightforward, and it'll be due a week from, let's say, a week from Thursday. All right, so this is a homework assignment. Okay. So before I get started, so I'm gonna kind of go over the main ideas, and then we're gonna get started with the lab, basically, so you can practice it. So before we get started with our first topic of web security, are there any questions?
No.
No questions? All right, great. So again, just for those of you that came in a little late, of everything that I said, the most important thing is remember that Thursday is the practical exam for the buffer overflow 2 problem. Okay, so ready for that. All right, so now that we've talked about that, let me switch over to the whiteboard. So I'm going to go to the whiteboard. And actually, I'm going to go to the white space first. And I'm just going to click on. Right, so you should be seeing the Brightspace. And if you look under 450, I've added a new module called Web SOP, which means Web Same Origin Policy is the topic of today. And as you can see, what I have in here is I have a PDF, some zip files. So the files are actually here, okay? And then there's going to be the Word document, right? So this is what we're going to work on today. But first, I'll kind of go over a lecture of it. And then after that, I'll start getting into the details of this. All right, so I'm going to switch over to the whiteboard. All right, so let's go ahead and get started. All right, so the topic for this week is Web Same Origin Policy, or Web SOP. So SOP stands for Same Origin Policy. Now this is basically, it's like a guiding principle for the design of browsers. All right, so this is used for the design of web browsers. That is to say, you know, Chrome, Edge, Mozilla, so all of them, you know, all of them actually use these browsers, right? So they use the, you know, all these companies that create browsers use this principle of same origin policy, and it should make a lot of sense why. So as you know, one of the key things whenever you log in, right, whenever you log in into a website is that you create a session, right? So you create a session between the client and the server. So between the client and the server, there's going to be a session established. And that session is going to, the session number is going to be stored in a cookie. It's going to be stored in a cookie in your browser, basically, right? So that pretty much establishes your authentication to the server. Maybe you're logged into your bank or you're logged into your email. So whenever you're in your browser, imagine you're in the browser and there's like tabs, right? And each one of those tabs could be a website, right? Could be a website there. And so you don't want to maybe click on this website and have that website access the cookie that has to do with the authentication for your bank, right? You want that separation of, you know, resources from one website to the other, because you could be right, you know, possibly right now you're logged into Brightspace, you're logged into Zoom, you're logged into your bank, you know, for whatever reason, you're logged into Facebook, and who knows how many other things. So you might be logged into a lot of things. And so all of those authentications would be stored in cookies, and they're going to be stored in the memory of the browser, right? In the browser's memory. So the question is, how do you prevent one domain of one website from reaching in and grabbing the domain of the other one, right? So that has to be controlled by the browser itself, by the software in the browser. A browser that didn't do that would be actually a pretty insecure browser, and you know, you should not use it. All right, so that's the basic idea, and so that falls under the term Web SOP, or same origin policy, and so that's what that's the topic for today, right? So that's what we're gonna focus on today. Okay. So web browsers interact with websites and web applications, as you know. And what web browsers do is that they forward HTTP requests to the website on behalf of the user. So you will use, you know, usually whenever you connect to the internet, you will use your browser to do that, right? So web browsers use a security model called same origin policy. The web browsers use security models such as same origin policy. Okay, so same origin policy, and or otherwise known as SOP. So for enforcing, and this is basically used, so this is used for enforcing access restrictions on web applications. So it's a type of access control on the browser. And in particular, it relates to jQuery and JavaScript, right? So it relates to JavaScript because if you remember when you took your JavaScript, you know, what was can anyone tell me what was the command in JavaScript to access the cookie via JavaScript code? Who can tell me what that was? How would you access cookies from JavaScript? Nobody? All right, so you had an object called a document object, and then that had a property called document.cookie. And that's it. You know, so from JavaScript, all you had to do was that, and you could access the cookie in the browser. But usually it only accesses the cookie related to that website and not to other websites, right? So maybe you wondered before, how does it know that? Well, this is where same origin policy comes in to ensure that it can only access its own cookies. However, as we will see later on, and as we start looking into the labs, the attacks have a lot to do with trying to steal things like your cookies, right? So how can you inject JavaScript, for instance, into a website to have it steal the cookie, right? But right now, before we get into that, we're just really looking at how the browser itself imposes access control to prevent this from happening, in particular as it relates to JavaScript. Another key term that you might remember is DOM. Right, so the document object model, and that DOM is basically the way that whenever you have an HTML page, you know that it's made up, you can think of it as a tree of objects, right? Where all of these objects are the different tags. So you can then access the tags via JavaScript itself. So DOM is an example, document.cookie is an example of DOM because you're grabbing the document object and from it, you're accessing the cookie, okay? So this is our basic approach, all right? So now let's look a little bit deeper into the same origin policy, or SOP. All right, so SOP identifies each website. So in a browser, right? So whenever you have a browser, and let's say your browser is connected to several websites, you know, website, your bank, Facebook, etc. So SOP identifies each website using three things. So let's say the SOP identifies each website using its origin. Its origin, all right, which is going to be a unique combination of several items of the connection. So the SOP identifies each website using its origin, which is a unique combination of the following. protocol, domain, and port number. Right? So these three things are what the browser looks at to establish, okay, I have a cookie that belongs to this origin. And then I have this request by this other object. Should I give it access? Well, it's going to ask, does it have the same origin? Where the origin is defined as a combination. So the SOP identifies each website using its origin, which is a unique combination of protocol, domain, which is the name of the website, right? So facebook.com, you know, jpmorgan.com, you know, something like that. So those are and the port number that they're using. So it actually even goes down to the port number, okay? And based on this, it creates what is called a context for each origin. So based on this, the browser creates a context for each origin. Okay, and that's pretty much it. It's as simple as that. WebSOP then, using this approach, can basically provide access control on all the different resources. All right, as I've stated many times before, given that we're talking about web security now, you know, we're going to start looking a lot more at, you know, PHP, JavaScript, you know, anything related to HTML and CSS, which includes the document object model. So, you know, hopefully you remember that. You should have covered that in, you know, 110 and 362. Okay. So now let's move on. So basically this implies, given that you have these contexts, JavaScript programs from one origin are not allowed to access resources from another origin. Right, and the example that I can give you, for instance, is the cookie, right? The other things, but the cookie in particular, for instance, that would be something that belongs to that the DOM of one domain. It should not be accessed by the DOM of another domain via JavaScript or what have you. Any questions about that, guys? So JavaScript programs from one origin are not allowed to access resources from another origin. And if you think about it carefully, you know, that's a very important principle. So I think, as I've said before in this class, everything is pretty straightforward and simple, actually. But at the same time, these things have very strong implications to security. It would be terrible if you were logged into your bank, you click on an email that gave you some spam, you know, and that opened another website in your browser, and now this other website immediately tried to access your connection, right, on the browser. Those are actually usually called CSRF attacks, and we will see them later in the semester as we look at that type of, as we do the lab for that. You know, that idea of, you know, let's say you're logged into your bank, and then you have your email also open, and you get an email. That's why they always say, you know, don't click on emails, on links on emails. You get an email, you click on the link, and boom, it opens the other website, and it only takes a fraction of a second because maybe you'll close it, but it only needs seconds in the browser. Remember, all of these are living in the browser. So really, if it wasn't for SOP, the first thing, this bad site, bad HTML site that opened, which has JavaScript in it, that's the problem. This one has JavaScript. This one supports JavaScript. And so this one would try to access the resources of that one. And if that were the case, it would steal your cookie. It would impersonate you as being you, and it would just send a transaction to your bank to wipe out all of your life savings, right? So obviously that would be really terrible, but thankfully, same origin policy was meant to prevent this from happening, so that, so that even though the JavaScript will try to do it from the bad site, it will not be allowed to. Why? Because your bank, you know, let's say bank one, you know, something like that, .com has that domain. Bad site will not be able to have that domain, so maybe bad site is just bad site.com. So already they don't have the same domain, right? They wouldn't have the same the other ones, but basically the origin relates to this idea, the same origin policy. Okay. Any questions about this?
No.
So hopefully it's making sense. I think this is an easy. You'll be surprised how easy this lab is. It's really straightforward. All that we're going to do in this lab is, you know, look at, okay, I have 2 pages in a frame or something. Can this page access the resources of the other one? That's really all that we're going to explore. So as I've said, you know, in web security, no. In web security, no. We start to consider other things, right, that are pretty important. One of them is going to be, you know, JavaScript. You know, because JavaScript is really the language in your browser, in your client-side browser, that's going to try to, you know, do things, right? So you're going to have to be more careful about JavaScript. And the other topic is the document object model, okay, or DOM. So you guys should know this one. Or DOM. So basically here, web browsers expose the contents of the web page, you know, of the web page using the DOM API, or DOM, using DOM, the document object model, okay, to JavaScript programs. Okay, as you know, HTML, you know, it's a hierarchical tree made up of, you know, so you know it starts at, it's got like HTML, right? And then HTML can have, you know, the head tag, body tag, and then the body can be made up of paragraphs and so on. And so you can traverse this tree to access the different parts of the website. So in theory, JavaScript can modify anything from the website dynamically. As you know, it can also access, as I said, individual resources. Okay, another element that's going to become important going forward is going to be the cookies. So what is a cookie? So we can define cookies. So cookies initially had a specific goal, and a lot of this has been changing over the years, especially because of companies like Google, Facebook, all these companies that depend on advertisements. You know, so they try to, they're trying to get all of your information, basically create virtual profiles of you. And so a lot of the data now they store in their own servers, but traditionally cookies were initially meant to be the place where you would have that data, and that, you know, that has almost completely changed. But cookies are still serve the purpose of storing important information in the browser. They're basically placeholders, so you can say cookies are placeholders for server provided data, okay, in the web browser. And, you know, the best example of this would be the session. So the session ID, you know, especially when you authenticate and you're logged in. So you have that session ID, and that allows you now to, you know, to know who you are in the server, for instance. So a cookie is a key value pair. So cookies are, if you think of a cookie, each cookie, let's say, is a key value pair, such as, you know, let's say color equal green, right? So that's the kind of information that you can store. You usually just, you don't name the cookie or anything. Just every domain, every origin would have one cookie, and then you can retrieve the data by the key value pair of, you know, something like color and green. And there's a few other parameters that are associated with cookies, like other parameters associated with them are like, you know, the expires, you know, some path, domain, etc. So some information there. But basically, they're little text files in the browser where you can store data. So in particular, for a lot of our labs, we are going to be concerned with the session ID, because if you are logged in, this is the client, and this is the server, and you are logged into a bank, every time that you send a command to the server, you're going to attach the session ID, right, which you're going to get from that cookie. So what a bad guy will want to do is they will always try to get that session ID and append it to a fake transaction, something that they have defined as a fake thing, but they will basically pretend to be you. So they're going to try to impersonate you, right? So a lot of the labs that we will do this in the rest of the semester revolve around that idea of trying to impersonate someone. So the cookie will certainly become very, very important. And we will see some very novel ways, very interesting ways in which you can just try to steal someone's cookie. And that will motivate why we need to basically perform a lot of input validation. All right. So just, you know, these are some of the background. So as I said, whenever a cookie is created or a session ID, after cookies are created, the web browser will attach the cookies in all subsequent requests to the web application. Okay, and that way, it'll, you know, that's how they communicate and provide some kind of authentication. So definitely then, you know, the attackers will try to get those from you. And the problem with the reason why we use cookies, as you probably already know, the problem is that HTTP, or the HTTP protocol, is by its nature stateless. All right. Therefore, web applications need some kind of session management scheme for associating all HTTP requests with a particular user and session, right? So that's the reason, because of that, therefore, web applications use a session management scheme for associating HTTP requests with a particular user and a session on a server. Okay, so that's the bait idea. And although this sounds so obvious or whatever, it's actually pretty important. Right? So this is an important statement because this is the security of everything that you do. Because of the fact that HTTP protocol is by its nature stateless and everything is being sent by packets over the internet, insecure network and everything, web applications use a session management scheme for associating all requests that come from that user as you're logged in with a particular user and session on a server. Okay, so this in essence is the problem. Okay, and the reason why, one of the main reasons why we have all these labs to see how attackers will try to exploit this system or mechanism. To keep this session, so to maintain session information, traditionally, we have used a cookie. So to maintain session information, we use a cookie. And that becomes the valuable thing that attackers will try to exploit. And therefore, the parameter, the controls that need to be in place for this revolve around this idea. All right, so that's basically kind of the problem as we've stated it in web security. Now we're gonna focus on a lot, some of the mechanisms that are used to prevent this or protect from this. And one of them is going to be same origin policy. So now let's look a little bit more into the details of same origin policy, or SOP. Okay. So this is a very important security concept for a number of browser-side programming languages such as JavaScript. So this will allow, if pages or code or whatever has the same origin, then they'll be able to access each other's resources. But they will not be able to access each other's resources if they don't have the same origin. All right, so the best way to understand this really is to look at some examples. So let's look at some examples of this. we said that same origin policy is determined by origin, which is determined by a combination of protocol, domain, and port. Okay, so now we're going to look at some examples and try to decide if websites have the same origin or not. Okay, so let's say that I have the following URL. So I have the following URL: http www.example.com dir page.html. Right, so the question now is, which one of these websites will have the same origin? And you guys tell me. So what if, let's look at this one. http www.example.com and then dir2 other.html. So what do you think? These two websites, do they have the same origin or different origin?
Different.
Why different?
Because you have, like, you have the there two instead of just a dir.
Well, but think about, how did we define origin? It's a combination of what?
Of the protocol, the domain, and the port.
Okay. So what is the protocol in this one?
HTTP.
Okay. What is the domain?
Example dot www.example.com.
Yep. And the protocol here, it's not shown, right? Probably port 80.
Okay.
So if it's not shown, let's assume they're both the same. So what do you conclude?
Is it just a different session or?
No. Just the definition of WebSOP is if they have the same origin,
Okay.
or they're defined to have the same origin if these three things are the same.
Okay.
They'd both be the same then, right?
So the question is, do these two things have the same origin, given the definition?
Also, it's the protocol and the domain are the same. So if the same port is, if they're the same, then it would be the same.
Yes, so port is not there, so we assume it's the same. They're both HTTP, they're both the same domain. So therefore, do they have the same origin?
Yes.
Yes, okay, yes. That's right. And what does that mean, that they have the same origin? It means that JavaScript in this page can access the cookie, the resources, JavaScript DOM of this other page. Do you understand? Suzanne?
Yes, I'm sorry. I was trying to.
Does it make sense, guys, what I'm trying to say here?
Yeah.
That's all it is, right? That's all it is. That, you know, the same origin policy will look at these things to decide, do I let this, I have this request in the browser of this JavaScript that wants to access the cookie of this other website. Do I let it or not? And so it's actually a very profound and important thing. I mean, you could lose your life savings when you connect to your bank if this wasn't there. Okay, so it's extremely important. So let's look at another example then. Let's say I'm gonna do example.com colon 81, which is the port number, dir and f2 HTML. What about that one? Same or different?
If the other two have the same port number as 81, then it would be the same, right?
Well, look at the definition. To have the same origin, you have to have the same protocol, domain, and port number.
Yeah, they have the same protocol, the same,
They have the same protocol, the same domain, but look at the port number. We're going to assume this one is port 80, given that it's probably the default one. So what would you conclude?
if it was 80 and the other one, then it would be different, right?
They're different. Exactly. So these are different. So let's just say no, not same origin. The browser will not allow this to access the other one. So no accessing DOM, no accessing through JavaScript the cookies or anything of the page. Let's try another one. HTTPS www.example.com and this, dir f2 HTML. What about this one? Same or different?
Different.
Why?
It's HTTPS, not HTTP.
Right, so a different protocol, exactly. So that's it. I mean, that's the mechanism as you're seeing it. SOP, same origin policy, looks at these things to determine, okay, should I allow it or not? Well, it depends on who's trying to access it. So obviously that makes sense. If this was HTTP, Facebook.com, and what about that one? And it has some JavaScript and it tries to access the data from this. What will happen?
It's different. It wouldn't allow it to access
What's different?
the domain.
The domain, right? Now, we all know Facebook, right? We all know that if they could, they would, in fact, access everything. But they can't, right? Because of that mechanism. Even if they say that they mean well, don't trust them. But the idea then is these companies know about this mechanism. So they find other ways. They can't directly get things from your resources, but they will find other ways of harvesting your data. Okay? So just be aware of that. But as far as same origin policy stands there, right? And it's really up to the browser to prevent different companies with different origins really from accessing the information that you're doing. So really, in theory, if Google were really respecting all of this, you search on Google, and those searches that you do in Google should be off limits to all the other companies. But we all know that's not really true, right? Because they're kind of sharing the information somehow. And it really comes to like Google is literally intentionally grabbing the data because they have full control of the browsers and then sending that data to their advertisers and then, selling it and all that stuff. But that's a different mechanism, related to their advertising, not really related to attacks, right? So attacks would be, if it's not Facebook, if it's like a bad site, definitely they're not going to share data. If this is bad site, Google will not intentionally share data with that site like they might do with their advertising machine. And so in that case, bat site is kind of on its own, and it's going to be governed by these rules of same origin policy. Okay? Even subdomains are not going to be allowed. So for instance, if I use the example of HTTP en dot example.com. So this one will have a different, it has a different host basically, right? Because it has that subdomain. So even that one will not be allowed. Okay, so this would be, so all of these are examples of no, 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 and so on. Is this idea clear, guys?
Yeah.
All right.
So even like a subdomain would not have access to it.
It does
Only-
not.
Okay.
It's not in its most. Now sometimes you can. So again, this is all. This is a theory, right? This is a model that you should have. But how Chrome, Mozilla, the other one, Edge, implement this can vary a little bit. Okay, and you can tweak it sometimes to be more restrictive or less restrictive. Okay. So just be aware of that. So it's entirely up to the companies to decide how they're going to implement this. But the model itself, the same origin policy, in its most restrictive form, should not allow that either. Okay? Now, SOP can present problems that are definitely valid problems. Like if you have a huge company that has a lot of subdomains, you know, like Purdue, maybe Purdue has the citg.purdue, and then there's the english.purdue and whatever. So in that case, they're all within Purdue, or PNW, but so in those cases, there are ways that you can make it a little less restrictive. But there is also the argument that it kind of makes sense that the CITG's resources should not be accessed by, you know, the English department. So that's why it was designed this way originally. Okay. And then after this, there's a lot of extensions to this. So there's certainly other things to consider. And this is always changing, as I said, because even though this was a model that was created some time ago for security reasons, the business side of this for those browsers, you know, like Chrome and everything, does influence it a lot and drive some of the change. Okay. All right. Are there any other questions about this?
No, I think I got it.
Okay, great, excellent. So if you guys got it, then we can basically go ahead and start thinking about what I want you to do in the lab. As you know, as I said, this is just a one-day lab because we really don't have to. You know, we don't have to spend too much time on this. This is meant to be more of a refresher than anything else. You guys have taken a lot of web development courses, and so you're certainly familiar with JavaScript and everything, cookies. So what we're gonna do is we're gonna go now to Brightspace, and we're gonna start reading the material there. So let's go. Let me go ahead and share this. So I'm going to go back to Brightspace, and you should be seeing now the Brightspace. I'm going to click on the module WebSOP, and you can see I have some things. So one thing you're going to need is you're going to need to download this zip folder that you see here, SOP, into your seed VM. All right, and you're going to have to set it up, given that this SOP may not be in your your VM. And so you're going to have to use the files provided here. So let me go ahead and download these so I can open them. So now that I've opened these, I'm going to downloaded these. I'm going to open them. So I'm going to unzip the folder. And it's somewhat big. Give it a second. What are you guys seeing currently? My folder?
Yeah, we see a bright space.
You see bright space. Okay, sorry. All right, so I need to then. All right, I've opened the document. All right, so let's go ahead and I'm going to share. I need to share PDF. All right. Okay, so now hopefully you're seeing my PDF. So as I said, this is a very short little quick lab. I've kind of modified this from what the Seed Labs does. So that's why I've given you that zip file basically. All you have to do, as I said, is take that zip file, open it in your CVM 1604, and it's going to be a whole bunch of websites. I mean, it's really, you know, that's what we're doing from now on. I mean, it's web security. So everything is always going to be just websites, you know, that we're playing with. This lab is, you know, as you can see here in the overview, you know, the security model of existing web browsers is based on same origin policy and provides some basic protection features to web applications. The objective of this lab is to help students get a good understanding of same origin policy. The understanding will be a precursor for other web-related labs such as the cross-site scripting, cross-site request forgery, SQL injection lab, and all of those. Okay, so that's the reason why we're doing this is just kind of to introduce that topic so the other ones make a little bit more sense. And hopefully I've done a good job of explaining this idea of the cookies and the same origin restrictions. Okay, so as I said, you don't have to follow what it says here about the lab environment because you're just going to use the 1604 VM. Okay, and download the files, and it really should just take one, you know, an hour basically to finish this lab, so it should be very easy point. So you really can skip all of this. All right, as you can see here, the goal of this lab was to practice with something called live HTTP headers, and then pretty much to get some background on JavaScript, DOM, and so on. However, I know that you guys are experts on JavaScript and DOMs and HTML basics, so I'm not going to have you guys work on these, okay? Instead, all that you're going to do is use the provided website and follow some of the questions in this lab to kind of see how same origin policy works. This lab is basically a simulation of how same origin policy works, okay? All right, so here, now I should say, for those of you that don't remember JavaScript and DOM, you can go ahead and read through this, all right? Read through this, it'll provide some background. Here's the document object model, as I kind of drew it out for you. So you take an HTML site and you can break it up into the different tags. And then here, I'm not going to require you to do this, but if you feel that you don't remember how to do JavaScript, because I do want to stress, guys, we're going to do a lot of JavaScript for the rest of the semester, right? So if you feel that you don't remember JavaScript that well, or the document object model, I would strongly recommend that you do this example, okay? Do this example. So as you can see, it's a full HTML page, HTML to HTML, and all you're doing is, so I remember like when I've taught 110, I always do this, right? I always do the JavaScript, and we always play around with the DOM. And so, you might want to just practice this. All you have to do here is you're going to take a website and you're going to print out this. So you're going to print out that tree using the code provided here. Okay? So that's one thing you can do. But as I said, that's only practice if you feel that you're kind of not, you don't remember some of these things. Cookies, I also talked about cookies. Right, and I gave a little bit of a background on cookies, and it's the same thing. So you can follow these instructions, create a cookie, and basically maybe do, like the number of times that someone has visited a page, and count that if you'd like. This one I'm not so concerned about, XML HTTP request. When we get to the other labs, I will provide a little bit more background on this, okay? But basically, those are just really refresher or reminders of these topics. So this lab is really meant to be, as I said, a refresher of the topic. So understanding DOM and cookies, so you can follow those instructions, right? And try to implement a cookie on a web page, cookie counter. Now, as far as what I do need you to do for the lab, I need you to just focus on problem 4.2, this one. So if you can see 4.2, task 2, same origin policy for DOM and cookies, okay? So this is what you will do for your lab. You just need to answer these questions using the provided website that I gave you. And as I said, it's terribly easy. It's really just that sometimes you will navigate from one page to another, and it's gonna say something like same origin policy restricted or access granted, etc. And then we can skip task 3 because that XML HTTP headers we'll cover later on in another lab. All right. So basically, in conclusion, for this 1 hour, very quick lab, all you have to do is this one, task number 2, SOP for DOM and cookies. You will use the code that I provided. So if I go to the folder, and if I navigate to that folder somehow, right, so I'm going to share the folder. So if you can see now here, the code is here. A lot of the code for practicing, right, is here. But really, you just have to follow the instructions and use one of these for to follow the examples of same origin policy. So can you guys see this page that I just opened with a little browser here, a little that I'm typing on? Can you see this?
No.
You can? Really? Okay, hold on. Okay, I'm
We
sharing.
see your file explorer.
Yeah, no, I have to share again, but I'm sharing now the page. Do you see now a little text box where I'm typing?
Yes, we see it now.
Yeah, okay. So basically, this lab involves this. All right, this is the easiest points you'll ever get. All right, in this class, all you have to do is follow the instructions in the PDF. And usually what's going to happen is sometimes you type, okay, www.google.com, right? And then you have to follow all these buttons, and it's going to try to view source, right? And then what do you see there in that error message? You see the error message?
Yeah, it says the same origin policy blocks reading frame body.
Exactly. And why is that? Because the page index when I click view source, I'm calling JavaScript that's trying to read from another URL. And because same origin policy does not allow, because they don't have the same origin, it gives me that message. Make sense? And so that's it. So what you're going to do is you're basically going to use this little page to kind of simulate, you know, the behavior of same origin policy and convince yourself that, you know, that it does work. So you have, as I said, you have all those files in the folder. Okay. So you're going to start up this one. It's called index.html. And then quite simply, and I have to share again, so I'm going to switch here. All right, so I go back to the PDF. All right, so then you're going to go to task number 2 and then just do this. Right, so the objective of this task is to illustrate how web browsers identify the origin of web applications and how access restrictions are applied on DOM objects and cookies. To illustrate SOP for DOM and cookies, we use a web page located, and I just showed you, right, the index page. That web page displays 2 web pages inside its frames. The first frame displays a web page located in navigation, or called navigation.html, and it's going to ask the user, to provide a URL for another web page to be displayed in the next frame. So that's exactly, so I have to share again, but so what that means is you open this one and then, you know, you type something else, you know, whatever, same page, right? You have to click go. Okay, and so you're going to play with this. Okay, and just follow the exercises as given in the lab. Okay, so if I go to PDF, then so it says, the first frame displays a web page located in navigation.html and asks the user to provide the URL for another web page to be displayed in the next frame. When the user provides the URL, a JavaScript program in the first frame displays the requested page in the second frame. Furthermore, navigation.html has 2 JavaScript programs that read the source code and cookies of the web page in the second frame. JavaScript programs in navigation.html can reference the DOM object and the cookies of the web page in the second frame using the parent.main.document and parent.main.document.cookie respectively. So that's the DOM JavaScript commands. Essentially, we have one web page that is accessing the resources of another web page. Recall that the SOP restricts JavaScript programs from one origin from accessing resources in another origin. We will use this web page in the forthcoming tasks to understand the SOP-based access restrictions on cookies and DOM objects. Now, one thing you'll have to do also is you'll have to create a domain, okay? So you'll have to create a domain in your lab, and that's where the instructions up here will allow you to do that, okay? So just follow, like this, okay? So we'll have to follow these instructions, maybe try with etc host and setting this up on Apache server. So that might be the hardest part of this, but you're already doing this for your project, right? Another way, another way you could do is create like a local host, right? And that's how you can reference the pages. So I leave it to you guys to decide, but basically set up a website in your VM with those files, right? And then once you've done that, then everything should work. So it didn't work for me because I haven't done that on my machine. All right, and then after this, so that's it. So you're gonna then basically you will answer these questions. So provide the following URLs to the web page in the first frame and report whether you are able to access its cookies and DOM objects from the first frame. Okay. Try to use some cross-domain URLs such as google.com. So that one worked for me because obviously they were different. In the URL bar of the first web page and report whether you are able to access its cookies and DOM objects. The web server is listening on ports 80 and 8080. So provide SOP lab 8080 navigation.html to the first frame and report whether you are able to read the DOM objects and cookies. And finally, not only are the cookies and contents of the frame under the restriction of SOP, several other objects are also restricted, such as history and so on. All right, so basically work on this, okay? And, you know, just provide some examples that when you're supposed to, when things have the same origin, you should be able to see the information, and when they don't have the same origin, you should be restricted. And that's it. That's the lab. As I said, I don't want you to waste your time having to do JavaScript things or cookie things if you've already done quite a bit of that. But just please focus your time on practicing this same origin policy. And as I said, this lab is actually important as a warm-up to the upcoming labs that we have. Does this make sense, guys? Are there any questions? Something not clear?
I don't have any questions.
All crystal clear?
Good for now. Yes.
Okay. All right. So hopefully it is. It's as I said, it's meant to be a very, very easy lab. So if you're having trouble with it, you're overthinking it. As I said, the one thing that you have to do though is follow the instructions in the PDF for configuring these pages on your VM. But just be aware, and everything is provided there very clearly on how to configure Apache server and how to configure the DNS and everything. And as I had said, this is also what you're doing for your project anyway, so it works out well that way. All right, so I'm just checking to make sure that I've given you everything. Now, there are exceptions to same origin policy. That's the last thing that I need to cover for today. So what's one exception to same origin policy? So remember, you have a page, you have a domain or a context or an origin, and that context or origin is trying to access the resources of another domain. So that is, your website bank.com is trying to say, I want to use something from this URL, othersite.com. I've said that same origin policy does not let that happen when they have the same port, protocol, and domain name, or when they don't have those. Can any of you think of an exception to that rule? What would be an exception where a website can access some resource of another website? What's an exception to that? Are there any tags, for instance, that can access a resource from it? Is there a tag in a website that can access a resource from another website? Can you think of one? Any ideas?
A tag.
Say that?
The link tag.
The link tag, right? That link tag can actually access Another link, right? That's what you're saying?
Yes.
Yeah, an even better example is the image tag, right? What about the image tag?
Or to get the image resource put on the web servers.
Yeah, right. You have one page, and that page, you know, has an image tag, right? And that image tag will go to any other URL and will retrieve that resource, right? So those are sort of exceptions to this, to the that blanket rule of not allowing resources from another place. Does that make sense?
Yes.
Yeah. All right. So that's pretty much it. Exceptions from SOP. So there are some exceptions to SOP in this task, and you don't have to complete this task. I'm just really going to talk about it. Some HTML tags can also trigger. Oh, are you guys seeing the PDF, by the way? No?
Yeah.
Right. So exceptions are, there are some exceptions to SOP. In this task, some HTML tags can also trigger an HTTP request within a web page. For example, the IMG tag in an HTML page can trigger an HTTP GET request. The question is whether SOP is applied here to restrict the targets of the HTTP request. As we all know, there's probably one thing we learned from the beginning. It's probably the first thing you learn when you learn about websites, right? Is images. You want to import images. So the short answer is that when you try tags like frame, iframe, img, and a, as some students said, SOP does not block that, okay? And so those are exceptions to same origin policy. Okay, and just be aware of that. We're actually going to see how we can exploit this. So we're going to actually see how we can use an image tag to steal the cookie of a program. All right, so we're gonna explore that. It's very interesting how that can be done. Where we can actually use an image tag to steal the cookie and then send it to another server. But that will be in the next lab. So for now, as I said, all I want you to do is kind of get acquainted with web security. I've kind of given this discussion where I talked about DOM, JavaScript. So if you don't remember it, again, familiarize yourself with it. Certainly practice what is in this PDF. Also practice setting up the website, as I explained, setting it up on your server. It'll be good practice for your project. And then after that, and I need to share this again. And then after that, complete the problems specified in task number 2 of using this, as I said, let's say www.cnn.com, right? You'll click on go, read cookie, and so on. And now you have to figure out for which websites you actually get access to the resources and for which websites you get this little message that says same origin policy block. Okay? All right, guys, so for today, I had only planned to cover this. And the rest of the time, I'm just going to dedicate to open it up for questions, given that we have our practical exam on Thursday about buffer overflow vulnerability lab 2. So this is your last opportunity in the time that we have left to clear up any questions that you may have on that exam, okay, the practical exam on Thursday. All right, so again, so to summarize for today, I introduced web security. I introduced the same origin policy principles or idea. I've given you one homework assignment, and I'm going to actually, before I forget, I'm going to create the Dropbox. So I'm going to create a link here. You should be seeing my, what do you call it? My Brightspace. And I'm going to create a new assignment. I'm going to call it WebSOP Lab. This is going to be due on the 15th. By 11 p.m. And all I want you to do is I want you to complete complete the questions. Sorry, I can't find the. All right, so I'm Brightspace here. So from the attached PDF, complete task 4.2 or 4.2 task 2, SOP for DOM and cookies. So complete the following. Using the attached zip file, right? And then as a note, I will say set up the website and configure the domain on Apache. Okay, using the provided files in SOP. That's it. All right, so hopefully that's clear. So from the attached PDF, complete the following using the attached zip file, 4.2 task 2, SOP for DOM and cookies. Note, set up the website and configure the domain on Apache server using the provided files in SOP.zip. Okay, and that's it. That's your lab assignment, which as I've indicated is due a week from today. Does this make sense? The lab, are there any questions?
No.
Pretty clear? Okay, great. So let me post this one. And then after that, as I said, I'm just going to open it up to questions. Okay, so that should be now created. All right, there it is. All right, so now let me just go back to the whiteboard. All right, so now to conclude today, now we're going to move on to buffer overflow 2. All right, so like I said, that's going to be a practical exam about it on Thursday. Okay, so Thursday, you'll get from 6 to, let's say, 9, 3 hours, work on it. I will open the link at 6. I will get online for that one, just to kind of, because I will post it and then I'll explain the question. I'll provide probably the ASCII table as well. Have your CVM ready to go. You can do it on your CVM, and you only need one CVM, and then, you know, you'll just have to solve the problem, and then you'll submit your lab report at the end of that session. Remember, it'll be related. It'll include basically everything, set UID, format string, buffer overflow. So it'll just be one, it's definitely just going to be one problem. But as you might imagine, I may ask you to provide a root shell, or I may ask you to do something along those lines. Okay? So now I'm going to pause the video at this time since I'm not going to give any new material. And instead, I'm just going to open it up to questions that you might have on this lab. Okay?